Okay, we're looking at the pump. The pump does have a valve on it, but when you are running it, run it wide open. The valve is here to use when you do your cleanup. You can shut the water down and it'll come into the tube with the handy cleanup here. But you want the water flow. The water flow is really important to driving the riffles on this map. And the way we found this works is the really, really fine gold ends up underneath the Hungarian riffles right at the top. It comes over the top and gets sucked underneath. The coarse little pieces of gold will get stuck into your riffles, the rubber notches here. But the Hungarian riffle is what catches that really, really fine gold. That's what we're all trying to catch. And it's why the Keen is calling this a miracle mat, because we'll get, multiple hundred mesh gold will get stuck underneath this riffle, and it actually tends to stick right between the edge of the riffle and that first notch. And we'll show that to you a little bit later on a close-up. Okay, I've started the device up. Each time I go to run a new batch, I check the riffles again, make sure we don't have any air bubbles stuck. The gold will stick in here, but any place there's an air bubble, again, it will not stick. So we're going to add some material. I want to show you this. We're not using white sand or anything that's really easy to process. We're using the most difficult material to process. This is really heavy black sand. Most of this is from Nome. Some of this is, the larger stuff is from the Yuba River. But we want to make sure that we're demoing this with the very hardest to use material. So we show that it does its job. So we're going to load it with a scoop right in this front plate. You don't have to be real shy. It'll run itself through very nicely. Now to the use of the chopstick. Just work any of that material. And as soon as that top starts to clear, add some more material. Okay, so as we load this, the coarser little pieces of gold will end up in the sluice down a little bit, especially if you're driving it to its maximum capacity, which is what I want to do when I'm working on dredge cleanup. You don't really have to worry about your microgold. It's going to get underneath that first 2 or 3 riffles and it's going to stay there. So if you see a little bit of the coarser stuff down in the sluice, don't worry about it. You're not going to lose any of your gold processing it. If you're really over driving it and see it down toward the end, slow down a little bit. But we're going to just continue to load this, and then we'll run through the rest of the process here in a minute.
Bob, I got a question for you. How many pounds an hour can you run? Let's say like a 5-gallon bucket.
We're running 2 5-gallon buckets in about 2 hours once we've classified the rocks off when we do dredge cleanup.
Okay, so you can run 2 5-gallon buckets in about an hour?
About 2 hours.
Okay, and that's concentrate from a dredge?
That's concentrate from a dredge, and what you'll end up with in your sluice is all your gold, all your lead, any other metals that you've got from your dredge will end up in the sluice.
Okay. Is that, and when you classify it for dredging, you're going to typically go down to, you said like a number 8?
Number 8 screen is what we're using on dredging.
8 mesh screen, all right. So are you talking about full buckets? Because a full bucket of dredge concentrates can weigh around like 80 pounds or something, or even heavier.
Well, when we clean up the 6-inch, which is the one that we're using 2 6-inches up on the Yuba, it's probably 2/3 full of the -8.
Okay.
So
that's a lot of material to go through.
It's a lot of material.